Okay, you can hear us? Thank you everyone for coming to this defense. Thank you, Sandy, for the introduction. I'm very blessed to have so many amazing people in my life to share this PhD with. I think truthfully, if we asked many of you what I've been doing for the last 4 years, you would have no idea. Maybe something about secure AI, but I think today is the one chance I finally get to tell you all what I've been working on. I'm super excited by that. The short answer to that question is private, verifiable, and auditable AI systems. So, the thesis to go along with this has 9 papers in it. There are going to be 3 parts, very technical. My goal today is to give you a sense of what we were trying to build, what the vision was, and then what we actually did to achieve that as we went along these 3 different parts. We will do a background explaining that title. If you guys look confused in person, then I will slow down, and if you're nodding your heads, I'm going to speed up. So you guys are in charge of modulating the speed of this presentation. Am I sharing the screen?
Don't look at us.
No.
We're the ones who probably know the most. So.
Absolutely. Am I sharing the screen? Can people see the slides? I'm just double checking.
See the slides. This is what it looks like.
I think we should share the screen.
Yeah, that would be better.
2 Sekarooni's team. That is what we're sharing. Now you can see the slides properly. Good? Excellent, team. All right, this is our agenda. Let's dive in. First, let's define what those title words mean. What is an AI system? There's lots of AI people in the room. Please don't be offended by this oversimplification of what AI is. For normal people, an AI system is just ChatGPT, something you interact with. It's an interface. In truth, an AI system is a whole process. It's a pipeline that starts with data collection, where for language models, we scrape the entire internet, and then we pass it through a pre-training process that makes this flexible, useful model for lots of different contexts. Then there is often a fine-tuning step, where we take a model and we either make it aligned to preferences, make it useful for a chatbot, or we fine-tune it for a particular purpose, like a legal context, to make it useful. And then, once we have a model, we serve it and provide it at inference. And that is what you're interacting with when you're using something like ChatGPT. Every step of this needs security. And that is part of the vision I want to get through today. But this is not the full extent of what AI involves. There are also evaluations of these models as we're going along the deployment of them, checking that everything is safe. There is actions, which is when the AI system is trying to do something in the world and making sure that's safe. There are credentials, how do we know what we're interacting with and what its properties are? And there is retrieval, updating AI systems with contextual, relevant, and timely information, e.g. using web search. So all of these things are in scope, and we want to build security for all of them. What is privacy? This is kind of an overloaded term in the literature, it can mean lots of things. This is a diagram from the International AI Safety Report that I had the pleasure of writing the risks to privacy and methods for privacy section. And we had lots of bureaucratic discussion of what is privacy. Privacy can mean training data privacy. So people worry about training AI systems on sensitive data. That is important, and there's tools like differential privacy to help address that. There is handling sensitive data in use. So when you're deploying AI in a context where it's going to interact with sensitive data and making sure that is safe and reliable. And then there are downstream harms from use, e.g. where someone uses a highly effective AI system to stalk you, right? Kind of the application of AI to impede privacy. Today's talk and my whole thesis is primarily focused on the middle one. What happens when you put AI in a sensitive context and you want to handle sensitive data? Right. There are lots of problems with training. We're not going to talk about them today. There is a huge literature on that. But I think it is an underexplored problem, the handling of sensitive data, and how we deploy that, especially with language models. Auditable, this word is the easiest one. I think at its core, my desire to care about auditability comes from hanging out with a lawyer all day. Because auditability is actually a very important tool when you're deploying any system in the wild. It is about what data went where, for whom, on behalf of what. It is very useful in the question of what training data was used, e.g. data provenance initiative. What model is being run? What access to data was relevant? This is a huge field. There are billion-dollar B2B SaaS companies just on figuring out auditability in enterprise contexts. So this is an important task. And then there's verifiable, which if there's any cryptographers on Zoom, I apologize for offending anyone. This can be interchanged with a lot of different words with very specific meanings, e.g. integrity, correctness, or creating guarantees. In general, it's about checking things are authentic, untampered with, and follow agreed rules. There's tools like signatures, zero hashes, zero knowledge proofs that we'll touch on in a second. I think this is actually best summarized by the Russian proverb that was then popularized by Reagan: trust but verify. You have a system, you assume it's going to work okay, but you want to make sure it is doing so as you go along. Okay, those are the 3 words. What is the goal here? Who here is familiar with the concept of ikigai, the Japanese concept of having a career in harmony? I told this idea to a bunch of people. I'm really worried about a lot of my friends haven't done enough self-exploration to discover this yet. It's this idea that you can balance what you love, what you're good at, what the world needs, and what you need to be paid for, and find balance between those concepts. And I view this thesis in some way as trying to find a balance between these ideas and what I can do. Which is that if you have private, verifiable privacy, you can have black box confidentiality. Really useful to just know nothing is leaked, but creates safety risks when everything is black box. When you have verifiable auditability, you can get really efficient audits, and that can be very powerful. But you can also exploit transparency and have scalable monitoring and exploitation of privacy. And if you have auditable privacy, then that isn't verifiable, that you can't check anything, then you just have a bunch of untrustworthy claims, which notably I can also do. And so kind of as the last piece of motivation of what we're trying to do to find that balance, I want to query the audience and the folks on Zoom, for those who want to type in chat. Who here thinks in the next 5 to 10 years, which is kind of the time frame in which a PhD can even remotely matter, AI will matter in enterprise contexts, just in a general sense? And hands up. Any takers? Some people just don't care. I think you're in the wrong room. There is a general consensus that AI is mattering in the world. It's being deployed. We need to think about security and sensitivity in very pragmatic contexts that happen today. Now, broader question, who here thinks in 5 to 10 years we will have AGI, or superintelligence, in kind of a broad sense? We have Michiel up the front. Who else thinks we will have AGI in 5 years? We have only the DeepMind employee, corporate capture at play. So I think even if we have AGI, right, super intelligent systems that are processing every facet of our life, I think security matters more and more. These are P-dooms, which for those who don't spend enough time on Twitter, is the probability you think society will collapse as a result of AI on some given timescale. Some people are very high, some people are very low. Clearly Michiel is much higher than the rest of this room.
The question was AGI, right? It was not P-doom.
Right, no, you're correct. It was AGI. You're allowed. You're safe. So 50-50 P-doom.
No, 15.
15%.
Yeah.
I think mine's higher. Which, regardless, I think one way to mitigate the harms of AGI is to have really robust security in their deployments. Point being, I think no matter which way the world goes, security is going to matter. Okay, I'm hoping you're all sufficiently motivated that this was a worthwhile PhD to attempt. Let's see what we actually did with that. We're going to need to do a background just to get everyone up to speed. There's going to be math. Stay calm. We're going to get through it. It's going to be super easy. I want to remind everyone that AI systems, even if they're scary, are just math. Pre-training data, the data used for training, is just a spreadsheet. As part of the Data Provenance Initiative, my key contribution was downloading the internet. I did it once, and then Shane said, not good enough, download it again. And each time I would download it and produce a spreadsheet. And it is from that spreadsheet that we would do downstream analysis. And so the point is, at the end of the day, you know what a spreadsheet looks like. You know we can work with this. Inference is just linear algebra. It's just doing some math. Evaluations on models are just doing that linear algebra, checking it was correct, and putting it in a for loop. And then agents are really, at the end of the day, just AI systems that click buttons, that do stuff on the web in the way you would, or make API calls. Right. How do we map this to cryptography and make this useful? Quick primer, those who did CS, this is a test. Those who didn't, hopefully you'll learn something. Hashing is this idea of mapping from a large state space into a smaller one to make it a number. It's going to be really useful. It's going to show up throughout. For example, if you took the word high, you made each of those letters ASCII, so just the number they're represented in the computer, 72, 105. You added them together and did the modulus operation, which just takes the remainder. Bear with me. You get a number. Point is, we can take any data, turn it into a number. It's going to be useful because we want to do signatures. Signatures are the idea that you have a document and you can sign the fact that you authentically had this document, which is going to be really useful. Again, this is just math under the hood. We pick numbers. One of them is private, which is going to be useful for sharing. We hash the message, that thing we just did. You're going to do a little bit of math with it. You're going to do this, the hash to the power D, your private key. Then someone else, when you send the message, is going to do some math. And at the end of the day, we just run this equation and check that the math is correct. When I say verify throughout this talk, just remember we're checking math is correct computationally. And it might seem confusing, but under the hood, it's relatively simple. This extends, we had to do all this setup to get to the idea of a zero knowledge proof, which frankly is one of the things I found most confusing in this entire field. Instead of proving we know a fact, we know a piece of data, we had it, we want to prove that we knew a piece of computation. So, what does it mean to know we have computation? We have a function f here that has a private input x. You have a prover, who is going to be the person trying to make a statement, and a verifier, someone who's verifying that this is correct. So I want to prove to you I know a private input to this equation that produces some output y. I do some math. Essentially, I just generate a random number, put the number into some equations, hash it again, spit out a new random number. I hand you a package of numbers, which we're going to call pi throughout this talk. It's standard cryptography nomenclature, which is just some numbers. And then you just check an equation, which under the hood is just checking that an equation, that one number is the same as another number. It's a super simple bit of math. But if you do this correctly, you can prove that you ran computation. And that I knew some private input that could run a thing. Okay, it's going to be super useful. Back to easy one, encryption. You might have done Caesar ciphers as a kid. It's the idea that I have a string like Tobin. I take all of the letters and I move them up by 2. It looks like gobbledygook, but it's really easy to turn it back. 2 here is kind of the private key. We can encrypt and decrypt. Okay, that's the end of the math. Everyone seems okay. No one's asleep yet. I don't know on Zoom, some people might be asleep, but at least the people in person are still here. These are our 4 ideas: scrambling data, signing things, encrypting them, and proving computation. From these 4 alone, we can go and do a lot of good things in AI. All right, are we ready for fun? We now actually get to part 1 of the thesis. We're okay? Brilliant. Okay, provable claims. Why do we want to prove a claim? Michiel, the committee member from Google/DeepMind, famously, Google DeepMind produces a lot of AI models. At times, you've made claims about AI models that were not necessarily 100% accurate, or an overzealous estimate of the capabilities in the current time of the model. Sorry to pick on you, Michiel. Similarly, you might remember when ChatGPT came out, took the world by storm, it was super cool, right? And then everyone started complaining that ChatGPT got worse. Because as the story goes, OpenAI ran out of GPUs and then couldn't serve the full model. So they served a quantized version of the model or a distilled version of the model, which is almost as useful, but not quite as useful, and people noticed. And the point is, when you're using a service, you have no idea what AI model you're actually being served. Right? People can do a lot of things behind the scenes and you won't realize. So how can we make this robust? And the point is, there are a lot of cost and efficiency reasons to lie to an end user about your AI deployment. There are also contexts where even if there isn't an incentive, there are regulatory demands to have verifiability. E.g., it's a healthcare model that's being used, using AI in healthcare. You want to know that it is an FDA certified model every time it is used. It's a super useful application of this. So, how do we know what model is being used? How do we make a provable claim about an AI system? I lied, there is more math. But this math has diagrams. This is pretty pictures. So, instead of this being a very simple function, our function is inference of an AI model. And the inference of the AI model is just a bunch of linear algebra, remember. The private inputs are the model weights, which we can keep private, and the inputs to the system. We share the outputs. Remember, this is just an attention, math. It's just linear algebra. And essentially, models, oversimplified, are just a lot of linear algebra stacked on top of each other. We make little proofs for each thing. We put it in a big table, and then we prove each one of them and concatenate it together. And that is how we get a zero-knowledge proof of inference, which you prove all the operations in sequence, you get this pi. You give this pi to a verifier, which can be anyone. It could be you guys. I could run a model, hand it to you, you run a tiny, tiny piece of code super quick to check that everything works. All right, that's the root of what we're going to use for the rest of this section. So what can we do with this? What's really useful about this? Well, one thing we can do is create an evaluation attestation, something I worked on while at MSR. And the idea here is evaluations are just running a for loop over a bunch of data to check how models perform. At the end of the day, that's all it is. So we run a set of these inferences of models, right, over an evaluation data set, and we get all these pies, then we put them all together into a verifiable evaluation attestation, which we can then send to anyone. You can post it publicly. The weights are private. You keep that fully private. This creation of an attestation would be done by a large tech company who has lots of compute resources, lots of time to run the model, do these proof generation. And then very cheaply, an end user, anytime they use a model, can get a new attestation of the model that's being used and check that the magic numbers, the hashes of the model weights, in this case, match. And that at its core means you can verify with 100% reliability. There's no way to fake it or spoof it, that the model that's being seen is real. Okay, this is very confusing, I'll admit. I think this diagram has far too many parts, but it is a really useful property that we can do. The actual problem, just between you and me about this research, is it's super slow. It sucks. The slowness is on the big tech company, so you can kind of push them to do it, but no one likes using slow things. It grows sublinearly and is useful for language models. This field is also evolving all the time. I actually just got a job offer to go and build this up at a scaled way by a big, well-capitalized company in the Bay that I did not take. But there is demand for this kind of technology to be deployed at scale, and it is genuinely useful. But it begged the question, how can we speed things up? So we worked on a new project. How can you make these AI systems faster? Well, one thing you can do is prove the whole weights of a system. But for the various people in the audience who deeply believe in open source, the benefit of open source weights is you can fine-tune them to do your own stuff. And kind of two general ways you can fine-tune, for example, would be LoRa, low-rank approximation, where you insert these kind of matrices into the flow. It's a very light touch fine-tuning approach. And in this instance, you don't have to prove the full model. You can just prove the trained weights, the weights that you changed. Same with fine-tuning the head of a model for a particular purpose, like a classifier. And so this dramatically reduces the overhead on doing this proof and makes this kind of system, broadly speaking, much, much, much more useful. And you're going to have composability of different proofs of systems. Okay, that's the AI part. We can do more than that. In the previous example, the root of trust is the evaluation data set. If it's a bad evaluation data set, it's going to be a bad evaluation attestation. This is a broader process where if you have a really good root of trust, you can make arbitrary claims on top of that. So this is a work on ZK tags with Alex Burke, but also kind of draws from the lessons in the Data Provenance Initiative, where if you have someone sign your pre-training data, just say like, they have an auditor come in, check the pre-training data, there it is, it's correct, that's what they used. You can then generate arbitrary questions and answers to that that are fully privacy preserving. So you could say, is the New York Times in this data set? And we could run a little bit of computation to generate a proof that says, no, New York Times is not in this data set. Or more broadly, how many things are in this data set? What is the language composition? You can answer a lot of questions as long as you have a root of trust in this. So this idea of provable claims kind of generalizes more broadly across the AI supply chain. Okay, that's the end of part one. Do we feel okay? All right, we're making progress. If it will click. This whole part is about verifying computation using these ZK-SNARK primitives. It's really useful for auditing systems. It's also really useful for preserving privacy and is underpinned by verifiability. You kind of get in the gist of the title here, right? It kind of writes itself. So that's part one. Let's talk about inference privacy and RAG. Woo! We need to get the energy levels up in here. Okay, we've all had this interaction. You go to ChatGPT, you ask it, what is this weird rash? And it tells you, go to the doctor. I am not a medical professional. This is the inference you're used to seeing. Very straightforward, runs through the model. There is an enormous amount of work that has gone into protecting that AI model in its deployment, introducing confidentiality, security, verifiability to this. Huge amount of work. I have some of it. There's a broader literature on this. There are also underexplored parts of the AI system, which is something I liked focusing on during the PhD. And one of them is the idea of retrieval augmented generation that blew up with ChatGPT. It's relatively straightforward. When you're running the model, Sometimes you want to access external relevant information to contextualize the response. The classic example is you do a web search on ChatGPT, you click the search button, or you use Gemini to do Google search under the hood. It goes and accesses information. Could access a medical database, there's lots of useful things. There are lots of threat models that come along with this. Anytime you send a request out to an external server to get new information in, to do a web search, to access a database, that server knows what you are asking for. So how can we introduce privacy into this workflow? Well, that's kind of the question. How does this workflow work? In general, this is kind of your AI background on this. You take your question, you run an embedding model. This is a general tool. You run an embedding model to get a query vector. That vector, you're then going to try and check against a database, which has lots of text. They're all embedded in a big database. Now, for the computer scientists, you would know this would take n time to do distance calculations to all of them. So it's much faster to store this in something called an inverted file index, which is essentially k-means clustering, where you find clusters, and you first find the distance of the cluster, that lets you get closer, and then you can just look inside of the cluster for the relevant documents. Really speeds up the process of searching for things. And without this, essentially everything breaks, but this is really useful. Now, how do we introduce security into this? Well, the first way was in collaboration with guys this kind. We explored using multi-party computation to secure this. So now you have multiple servers providing different information. All these servers can work together to provide information to an AI system. You can almost imagine a community collectively pooling data to answer a question. We do federated k-means. We store it in this inverted file index. It's super useful, and then you can do the usual querying flow, where a user makes a question, sends that request off to the servers who all communicate to do this inverted file index search and return your response. It can be really useful. Totally makes it secure. Once again, and this is only the second time this theme will come up, it's kind of slow, to be honest with you. The problem is that your trust is shared amongst multiple parties, so they need to communicate to establish trust and give you an answer. And communication is a really expensive overhead compared to pure computation, and so speed blows up. So how can we make this better? This is presented in a reverse order of operations, because before I wrote that paper, we wrote a paper called Community Transformers that used something called a trusted execution environment, which is a little secure piece of hardware on your computer that guarantees the computation that happens in it. Doesn't have to use all that complicated math we talked about before. It's a nice piece of hardware. And the problem is, in order to send and make any of this useful, you need a GPU. And there was no way to get security on a GPU. But since that paper came out, and today, the new H100s from NVIDIA have a secure enclave. So you can now create end-to-end secure attestations between the trusted execution environment, which is handling the flow of all of the data, sending stuff to the GPU, which we know is secure, we have this little hardware security on it, and then accessing a secure database. And you kind of end-to-end provide security in this whole workflow of AI, which is super cool. Which there is also a startup coming out of MIT building on this idea with some good friends. So good things are happening in this space. This is very useful technology. And that's it. That's part 2. We're making good progress, team. Everyone looks a little tired, but we're going to get there. The key thing here is you sometimes need external data. That's really useful. You can be made auditable by the careful design of systems, e.g. using retrieval augmented generation. And that makes it really useful to do logging and tracking and transparency. But you need privacy. MPC, multi-party computation, and trusted execution environments can enable that privacy and integrity. Cool. We feel good? Let's do part 3. This one gets fun. This one's a little future-looking, almost. We're going to talk about AI agents, which, if you're on Twitter, you already know what that is. And if you're not on Twitter, congratulations. You're just living your best life. Well done. So we have the same question. Before we were retrieving information to answer it, but this time we want it to do something. We want it to go out and make us a doctor's appointment. Right? This is useful. This saves us work. This is the vision of AI making our lives better. But once again, we are faced with the problem that there will be security. Before we get to that, the key thing you've got to remember is this is interoperable with the rest of the parts that we're talking about. E.g., you can do retrieval augmented generation before going and accessing a tool. But regardless, you need to think about security and how this interacts with web tools. Okay, now let's talk about part 3 of this security. Risks from AI agents. It's a bit of a wordy slide. Bear with me. Who has seen this recently? I would like a show of hands. Good. You're all human. That's generally good. Maybe Glenn might not be. We're seeing a proliferation of bots on the web, mostly for scraping data for pre-training models, but also for agents trying to do stuff. And a natural response that many people have as website owners is to block the bots. This is good. Stops having things scraped. We saw from DPI that there's a proliferation in robots.txt and bot blocking. I'm seeing this in day-to-day life. There's lots more like Cloudflare, are you a bot? Those captures, like, is this a car? There's two things wrong with this. The first is that AIs are getting much better. And so the AI can tell you what is a street light and what isn't a street light. Like, that's not hard. We've solved that. This is not effective. There are ways you can really enforce bot blocking. For example, you can require government ID to log in. Right? This is actually happening in Australia for social media. Right? You have to prove your age, but in turn, this also blocks bots. That's a tongue twister. We have a paper called Personhood Credentials, which is about how can you do this in a privacy-preserving way, right? Have the root of trust be real identity systems, but still preserve privacy online. But that's only half the issue. Because if you block all the bots, then you can't use your bots, which I would like to have a bot because I'm lazy and would like it to do stuff for me. One such example, I never know what my RA status at MIT is. So I asked OpenAI's operator to log into MIT and check my RA status, and it will do this. It loads up a web browser and goes and starts surfing the web, clicking various buttons, and then it's going to get to the Kerberos login that everyone from MIT is used to, and it's going to type in your password and username. And the honest user experience says, pinky promise, I'm not looking, type in your password, it's okay. And then once you log in, it saves the cookie, which means when you use it again, it can go back to MIT. Firstly, this is just a privacy nightmare. Like, I pinky swear I'm not looking is not how security works. It's also really bad from the angle of this system now has full access to my MIT account. It could unenroll me, it could buy a bunch of stuff, it could send emails to Sandy, I'm not sure he'd read them, but regardless, it can do a lot that I don't want it to do. We're purely relying upon alignment of the model to not go astray. Now, this is fine in an operator sense. If we have highly autonomous agents, you have your AI assistant that's helping you, then having it free reign access to MIT is not a good thing. This is not safety at all. So how do we do kind of pragmatic safety as part of this? Right, that's kind of the second key risk. Well, the good news is we actually had this issue before. Long ago, probably longer than I remember, longer than many people, given the ages of people in this room to remember, sites would ask you if you wanted to add a Google Calendar extension. They would ask for your Google Calendar password. You just type it in, they'd save it. And that was bad. So we stopped doing that. Now, when you want to give Calendly or something access to an account, Google account or whatever, you'll see one of these pop-ups. It's the login as, and then it will say, do you want to give access to X, Y, and Z? Do you want to give access to your calendars? Do you want to give access to your emails, etc.? You choose what control you have. This is an internet protocol that a bunch of nerds figured out was the right thing to do to build security. They made it really robust. And now, when a third party wants to access a service, they use something like this to log in and credentialize access. My key message to all of you is that we can use this lesson and bring it into the AI age. And so what does that look like? We had a paper called Authenticated Delegation and Permissioned and Authorized AI Agents and Authorized AI Agents. And this paper, for this kind of simple idea, got more hype than any other paper I did in the PhD, to the point where people sent me GitHub repos on LinkedIn. They just cold DM'd me with code, because they thought this was an important problem. And we're seeing with proliferation of stuff like MCP and these other protocols that security and access and authorization is critical to making sure that we actually have safe AI agents that can do stuff. Okay, so what do you need at a high level? You need identification. You need to know that this is an AI system. You need to know its properties. Can it do vision? Can it do text? If it can't do images, don't give it images. If it's a medical bot that's FDA approved, but it's only approved for text, don't send it a scan of my leg. It's going to give you the wrong advice. So there's some kind of credentialing that's going in there. There's authentication, making sure it's actually owned by me, and I've confirmed its action. I've said OK to that. And then there's authorization, which is making sure it has the right restrictions on what it can and cannot do. E.g., if it logs into MIT, it can check my RA status, it can interact with things, but it can't cancel my status at MIT. So, kind of seems simple, but we can package these together in a bunch of tools that are really useful for AI systems. And increasingly, that is what I will be doing over the next many moons, both at Stanford and in the commercial sector, to build out tools for really robust security for AI agents. And there are lots more academically interesting things here as well around the delegation of authority and what that looks like from an underlying protocol, which I know sounds kind of boring when I say it out loud, but I swear it's super cool, and I am super excited for it. And okay, that's part 3. The key lesson being that human impersonation and unrestricted access is risky at the best of times. It is made exponentially worse at scale and with systems that are highly autonomous and unconstrained, potentially unaligned. So, how do we solve that? We need tools like authenticated delegation and access controls. These can be made privacy preserving, they can draw on credentials, and they can be made verifiable using the basic cryptographic primitives that we talked about at the start of the talk. Kind of coming full circle. So, let's bring it all together. Right? We just talked about 3 parts and kind of a motivation. How do these things fit together? Well, we talked about data collection and scraping the web. We can do data attestations about that. We all agree that that's something we can do. Well, that data will then get fed into the training processes, pre-training and fine-tuning, both of which definitely need evaluations, which we can make verifiable. We have the tools to make them verifiable and robust. Once you've trained those models, you can then serve them to users and make it really useful. This is ChatGPT. This is all the tools that you're using in Microsoft Copilot, my mum uses. Even when you're using tools like Microsoft Copilot, it needs to do retrieval. It needs to access your documents. It needs to access the web search, give you relevant, timely, contextualized information. And in an ideal world, these AI systems can take actions out and about, which also needs security. So how do we secure that? We map that to credentials. And those credentials can draw on the verifiability of those evaluations and the claims about data attestations. And it all kind of fits together into one nice package. And that, in short, is the vision of the PhD, is to create private, auditable, and verifiable systems. These things are in tension, these ideas are in tension, but cryptography can combine and enable them to help build safer and more robust systems, and hopefully a safer and more robust future. So, thank you very much. That's the defense. Good time. Do you want to do acknowledgements?
Sorry?
Do you want to do acknowledgements, or?
Sure. Go ahead.
We can do the
Then
questions now.
Questions, yeah.
I think acknowledgements will be fun because there'll be questions about the
Okay.
acknowledgements. So this is the part where everyone starts crying during the defense. And I am very, very, very lucky to have so many people at the Media Lab and broadly in my life to thank who have been part of this PhD for me, who have helped support me along the way, who have taken me on crazy adventures that I never thought possible, while still somehow attempting to get papers written while on those crazy adventures. And yeah, I'm genuinely speechless with how thankful I am to everyone. And I will thank some specific people, but in order to not get too emotional, I'd rather this be a data-driven set of acknowledgements. So I arrived in this country 3 years and 9 months ago, 1.3K days. And since that day I arrived, I have kept a spreadsheet of every single day of my life with who I saw, where I was, what I did, my sleep, my activities, my heart rate, everything you can imagine. Now, I'm not going to provide a comprehensive analysis of this because we would be here for a while. And when I did this a few years ago, I got in trouble for some of the things I said. So instead, let's focus on some key and friendly metrics. I'd like to thank Sandy, my advisor in the PhD, who has been immensely valuable both in bringing me here and giving me this opportunity, and in advising me. And you say, how much did Sandy advise me? Well, I interacted with Sandy a total of 176 times throughout the whole PhD, which is actually an average of about 1 on 8 days. Once every 8 days. However, I looked, it's very clustered. There were times of a lot of Sandy and there were times of not much Sandy. That said, Sandy, you sent me 1.5k emails in the PhD, which is more than 1 a day. I've included an exemplar email of what it's like to be advised by Sandy, where he sent, going to Mars, no content, PDF attached. Which I think gives a good experience of what this PhD does. Very fun. If you're curious as to what it is, that PDF is about monetary systems for Mars. Fantastic PhD. You can't get this anywhere else in the world. Across the PhD, I got 7.5 hours sleep on average, which I actually think is quite good. I have this strong peak right before 8 hours, because I always set my alarm for 8 hours later and take a little bit to go to sleep. What a healthy PhD we've had here. The union would be proud. My caffeine intake has, however, increased over the course of the PhD. I would also like to give a heartfelt apology to those of you who were friends with me each time I quit caffeine in this graph. I was very grumpy. I know it. I'm sorry. It will continue. According to my spreadsheet and almost every other metric, 2024 was my most productive year. It was also the year in which I traveled the most somehow. And we'll come back to why I think this might be my most productive year. 25 papers were published, which I feel great about. However, it's worth noting that 7 of them have either 0 citations or have only been cited by myself. So you know, not everything was a hit. And then I have killed 9 plants in the PhD. You can see one of them in the office currently, if you'd like a tour. Oh, and I weigh 8 kilograms more than when I started, which I think broadly speaking is okay. Could have been worse. In particular, I genuinely have to thank my best friend in America, Robert, Dr. Robbo, who defended this morning, who has not only been one of my deepest, closest collaborators. We co-authored almost everything of value in my PhD, but also not the 7. No, Rob is actually co-authored on most of those 7. Rob was also my travel buddy for so many adventures, going to the World Economic Forum, staying in absurd, capsule hotels in Japan. We have had so many phenomenal adventures. Here are some cute photos of us together, often on planes or in airports. Based on some statistical analysis, it's worth noting that Robert actually hated me at the start of the PhD. He found me quite annoying, and I've slowly been wearing him down over time. Such that if you look at the curve, you'll note that 2024, I spent a lot of time with him. I think that drove a lot of productivity. The unfortunate bad news is MIT, so I did a rudimentary statistical analysis, and it would appear that we are going to fuse in 2026 into a hive mind. So stay tuned for that. Could be a rough year. I would like to thank the various Aussies, both in the room and on Zoom, to my 2 Australian best friends who have flown from various parts of England to be here right now with me and gallivant around New York after, and to my parents, seen in the only format I really see them, which is via Zoom or FaceTime, usually in bad photo shots. I love you all. Thank you very much for being part of my life, for getting me to MIT and then getting me through it. And I'm hoping continuing to help me along, but you're welcome to tap out now if you'd like. I would like to thank the various mentors, particularly my committee. Each of you 3 have helped me in your own unique ways, in very different ways, but it have genuinely added so much to my life. But also to the rest of the mentors that I have in my life. I'm very lucky to have great people who have helped me. These are just kind of the mentors that have helped get me here and get me along the way. There's also a lot of peers here that I've learned from that I genuinely need to thank, but you're not really going to get covered. That is the gist of the acknowledgements with no crying involved. There is more data analysis to be had that you will not be subjected to, but I'll be attaching an appendix later for anyone to review if they would like. Genuine thank you to all of you. I love you all. Thank you. Cool. Now you can come.
Okay.
And thanks to the Zoom people as well.
Now we'll get some questions.
Now we do questions.
So usually we start with the committee. So, Glenn?
I can maybe start with a with a general question, because your paper made a lot of waves, but like
Authenticated delegation?
yeah, But it also feels, for me, reading this as someone who's not from the security side, it's like, this is a solution, and we have a bunch of solutions in this space. But like ultimately, these are sort of, I often feel in like AI safety, AI security, we're solving like policy questions with like technical papers. And so maybe to put it on its hat, what do you think is like, if you were in the White House, which you might be in the Australian White House one day, what is like,
Green and Gold House.
What are like the policy things you would do to sort of make the internet ready for like agents, authentications, security?
So I think that's a really good question. I don't think policy will move fast enough to respond to the needs created. And I think really the way this works is a series of things go wrong and the internet responds. So I think agents start propagating across the web and causing all manner of havoc. Then everyone blocks the agents. And then the large AI labs that want to provide you an agent, Google, Anthropic, OpenAI, say, hey, I know you just blocked all of our bots. What if you gave us a tool to access it securely? And it is the demand from both the blocking side and the wanting to use the internet side that converges to a solution that lets secured access through. So I actually think no policy is needed. If there was to be policy, and there's a lawyer in the room, so I will get whatever I say wrong, it would be to have a hand-wavy nod towards you should support NIST standards for security whenever deploying AI systems, which in some ways might be more productive than a lot of the safety conversations and regulation, which is like, if it's over some number of flops, go to Europe, I don't know. So I think regulation is hard, but I think it's a good question to think about.
I think it kind of follow up on Mikhail's question, but
sort of on the opposite side, which is like the user experience. So it seems to me that like a huge aspect of what is really going to take to have like a meaningful authorized delegated authorization framework is very related to like the issues that come up around terms of service, which is to say, like, you can make people take some action, but getting them to actually process the information and make a meaningful decision about it is a completely different question.
This is great.
And the problem that you're going to run into is that the better agents get, the more people are just going to like set up some like super agent inside their computer that just clicks all the things for the authorization, and like it kind of undermines the whole point of actually getting them to take the accountability.
Yes.
And then you're gonna have to like give them a test, but then they can like have an
then the AI
cheat
does
on
the
the
test,
test,
yeah.
Of course.
and like whatever. And so the question is like, what is the actual sort of user experience, socio-technical process by which you figure out the things that you really do need people to have absorbed and get them to actually absorb it in a meaningful
So
way?
I think this is a great question. We held a workshop at Stanford where we tried to convene people to talk about this. And another way to describe this is consent fatigue. It's like the cookie banner, where you just stop caring about the cookie banner at some point. It's the point where people write bots to click accept on the cookie banner. And you can imagine if you have to click all these buttons to approve everything, it becomes really exhausting. And someone from within the OpenAI org who runs product said users don't care. They want to say, robot, do the thing, and robot does thing. They don't really care about clicking any other buttons. And so how do you keep a human in the loop securely without overloading the human? And in particular, I think this matters most for access controls. So you want an AI to go and do a thing repeatedly in a system. Maybe run autonomous experiments if you want to embrace a kind of AI safety question. You want AIs running autonomous experiments, needs to spin up GPUs, access resources, purchase training data. You want to give it enough scope for it to do what it needs to do, and then selectively restrict that scope for a given task so it doesn't go off the rails. And so we've had lots of conversations about dynamic interpretation of access controls. So you, in addition to telling an AI a task, set out a separate prompt that's protected from prompt injection attacks, that's kind of standalone, which is what is the scope instructions, and have a separate language model who's kind of an overseer interpret your scope restrictions into like resource-based access controls deep in the system that cannot be violated. That is very flexible.
Papers, right?
That is not a paper. We are working on that. It's kind of nodded to in some papers, but doing this robustly is really hard. It's kind of mentioned in the paper, but it's tough.
So let me ask a related question to this, and the meeting we had at Stanford, which is, the way you're talking about this is particular people having particular desires, moving back and forth, sort of wrestling with the economics of this. But what you really want is you want companies to really try to do the right thing, and you want people who are very lazy and don't know a lot to make the right decisions. Do you have an idea about that?
So you want companies to behave and you want humans to behave, but companies have...
companies to want to behave, not just to behave, but to actually want to behave.
And they have perverse incentives, and users are lazy, is what you're saying. So how do we fix that? Well, I mean, there's the regulatory answer, which makes sense coming from a European. But I think... I've really thrown you under the bus on this one. There's litigation, right? That's the American answer. Thank you, Glenn. Right, we take everyone to court.
I have European fines with me. So
Okay, ready.
I will find you if you say
Good,
that
good.
wrong.
I'm not setting foot in Europe. I'm going to London. It's fine. It's safe. I think putting aside litigation and regulation, I think users respond to harms, right? You've used a service before where like you get hacked. And you say, all right, no more, like I'm going to be careful when I click emails and make sure I check it's the right person. And then Google sees that demand and it gives you a little like, this is a verified email, you know, this is an unsecure email, puts it in trash. And I think companies have the same thing. Things go wrong, it hits the bottom line, and then they respond to it. And I think a bunch of bad things will happen, it will cost a bunch of people money, and then we'll have security. It's my pessimistic view.
Maybe one solution to that is that you actually have the AI system deliberately look for the places where you're delegating a lot to it and sort of fuck with you a little bit in those spaces in order to like not, in order to like show you what could go wrong.
Right. Adversarially prompt you, like the AI is training you to be better.
Yeah, well, like in other words, like it's like looking for the places where you're delegating to it and then screwing with you just enough to like remind you that you've given up that thing, and therefore you better take whatever it's going to give you in that space.
Yeah, that's a great
So
idea.
traditional answer to this is you get groups of people. So we'll call them unions or co-ops or whatever, because each individual person doesn't have the bandwidth, capability, and we're lazy. And that's really the motivation, is you need those sort of resources to be combined to fight companies who have lots of resources.
If only we were working with some kind of consumer representative union,
how
like
would that
Consumer
happen?
Reports at Stanford.
Yeah,
Ridiculous.
okay, yeah.
We are working with them.
We're working with consumer.
That was a loaded
Right.
question. No,
But let me ask you a slightly different question, which is, so you're going to have this sort of thing representing you. Right? How do you know that it's actually doing a good job? It could be completely legal, it could be completely normal, but it's not what you want.
So there's two parts there. There's like alignment of that, and then I think there's observability, and I think they go hand in hand. Is you can't know whether or not a thing is doing what you want unless you know what it's doing. But the problem with knowing what it's doing in highly autonomous scaled system is it's doing a lot of things very quickly. And so tools like these auditability tools, verifiability tools, let you get scalable insights into what is going on in the system. And that, I think, is not an answer to the question, but is part of the feedback loop in making systems that better represent you and are better loyal and more loyal.
What about observability of the person?
I mean, depends on who's, like, is the company, like, I observe myself sometimes, not always.
People aren't actually really good at it.
I guess. Well, we can't solve self-awareness. I'm declaring that out of scope for the PhD.
Oh, come on.
But I think like this is a real question of how do you create the feedback loop where AI systems can monitor the engagement of humans, maybe probe them adversarially, and then how can you have the human have insights into the AI system, especially when the AI system is much more autonomous and much more powerful, at least in the number of actions it can take per second, than a human.
You had your hand up.
Yeah, I have a
It's gonna be
question.
tough. I can feel it.
Sorry. I have a question similar to Sandy's about like how do you make people care? Because as we saw with like the threat of the TikTok ban, it kind of became a joke of like, I don't care about my data, China, because Chinese government can like take what they want. And so I really appreciated your answer of saying like people respond to harm for better or for worse. This is kind of a bit of a doomsday question, but is there an impending crisis that you foresee that's on the horizon based off of the current state of things?
I'm not going to respond in a public forum to the second part of that question. But the first part of that question, I think, has a nugget of really interestingness. So for those on Zoom who couldn't hear, Nana talked about the TikTok example where everyone jumped to the Chinese Red Note app because they don't care. They're like, take my data. And there are studies that have shown that if you ask people to pay for privacy, like would you pay $3 for Facebook to not use your data? People are like, nah. Like people have no willingness to pay for privacy. And yet, the internet has continued to evolve with better and better privacy tools, even if no one was ever willing to pay. And it is because coalitions of people come together to design more secure systems.
And we call that coalition Europe.
and that is Europe.
Thank you very much.
Drops mic. And so, if there is an impending set of challenges to the rights of citizens, gestures broadly and non-specifically. I think there may be coalitions of people that come together to protect the privacy of individuals, especially those who feel threatened. And I think actually having external threats can be catalysts for putting in stronger safeguards. Not that things are good in the process.
See that initiative being spearheaded at the community's level?
I think a combination of people at tech company are peoples. Like they're real. Like they do want to make things better. There are incentives sometimes to introduce privacy, especially when you have this combination of deploying tools at scale with a little bit of privacy that lets you deploy them more. Like there are reasons you might want to do this. There'll be companies, there'll be coalitions of people, there'll be social movements. It's all kind of an amorphous.
Hypothetically, if there were a group of people who were subject to harm, who also happened to be involved in the production of a lot of technology,
Hypothetically.
such a group of people might be such a
Extremely hypothetically, of course.
Well, so another alternative theory, right, is that it's something like law enforcement, right? So what is it, about 5% of GDP is fraud? Think about what you could do with so that's like on the order of $5 to $10 trillion a year of fraud, right? So maybe you'd like to stop that and do something else with it, right? So I think a lot of things have been put in place because of those sorts of things, right? So maybe what we can do is sort of pose things such it looks like that sort of bad stuff, and everybody agrees we ought to stop.
Well, and there are countries where it's more than 5%. So we go specifically to the places that are most inventive and
They don't have
the
that
highest productivity in
So
the fraud
the
industry.
World Bank sort of estimates that if you look at corruption, which is sort of fraud that's been made legal, then you get about 20% of GDP.
All right, more audience questions. Hopefully some of you understood it.
How many people understood it?
Put your hands up.
Hey,
Come on.
Pretty good. That's pretty good. Okay.
There's a Zoom question. I guess.
Oh yeah, would you like to ask Yost a question? I guess
Yeah, so Yost, what's the most interesting overlaps historically and prospectively going forward between your PhD work on privacy, audit, and verifiability and your office mate Robert's PhD work on auditability?
Thank you for reading that question from the chat, Robert. I mean, I think in many ways the reason I do the research I do is because I have Robert in my life, contributing legal analysis to all of my papers. And in many ways, the only reason Robert knows anything about AI is because I am in his life. I'm going to throw that shade.
Oh, wait a second. We just gave him a doctorate.
You delayed the fuse.
That's it. I think that is a good question. I think computational law, one of the things Robert talked about in his defense this morning is agentic self-governance, which is where AI systems kind of self-impose restrictions on their use and what they do for safety reasons. That has a big role in security. How can legal dynamism play a role in security? E.g., security is a spectrum between completely insecure, complete no privacy on anything, to black box. Everything is private, you can't see a single thing, you never see anything. When everything's fully private, it's not really useful. Like imagine a messaging app where you sent the message, but you couldn't see the message you sent, and the receiver could not see the message. If no one can see the message, it's not a useful messaging app, right? So at some point, you need to have little bits of visibility. And legal dynamism, for example, could take AI systems, and they're fully private, but as bad things are happening, as risks emerge and it identifies risks, it surfaces observability. It surfaces auditability and verifiability tools and leans away from privacy and towards auditing and self-governance. So it's a fun question. It's good. Captured interest. Any other takers? Shane.
Are your spreadsheets secure, auditable, verifiable?
Are my spreadsheets secure, auditable, and verifiable? Fundamentally, no. They are run on Google Docs, which Google, and it's a personal account, which means Google has said that they will train future versions of Gemini based on your Google Drive, which means there is a non-zero chance my spreadsheets are in the pre-training data of the new Gemini 2.5 model, which is why it's so good. Other question, that was a great question. All right, both you answer simultaneously. John.
So very high level question. So all of this research was great work, I think very important.
Mm-hmm.
If you need a commitment also from companies or all these startups putting out all these models
Mm-hmm.
and which are gonna be based off proliferation of AI agents.
Mm-hmm.
Do you think there's a role for regulation on part of the government? What are your thoughts on that? How do you encourage them or force them to actually adopt this kind of approach and framework?
Y'all love regulation. I don't think we need any regulation here. I honestly don't. A lot of the work to fix this, maybe. I think a lot of the work in fixing this is in the
guys,
system. See you later. A lot of people are focusing on regulating the AI models, right? And what can be released, what's acceptable, how do they need to be trained, whatever. And then the EU AI Act focuses on verticals, right? Like on use cases, right? AI in education has different regulatory demands to AI used in, creative work. And in many ways, security is a use case dependent need. Finance needs high security. Healthcare, super high security. You making Studio Ghibli art on ChatGPT, pretty low security. And so I think it is actually up to the sectors and verticals or to people providing internet infrastructure to at least make the security an offering, even if it's something you turn on and off. It might be off by default, and then when you go into a healthcare domain, you turn it on. Or if the internet evolves over time, it's on by default. And so I actually think it will be up to individuals in different sectors to implement this and scale it up.
What if OpenAI doesn't want to implement it as a principle?
They might just not care. So what if OpenAI just doesn't care? They see this talk and they're like, that's dumb. Yeah. We have infinite money. No one cares. I think there will be an ecosystem of agents. Some might support more robust security than others. And it might be that healthcare systems block the OpenAI operator bot because it's not secure, but they allow the special MIT secure bot to do things. And that might create a demand for OpenAI to implement security, at least for some of the verticals, et cetera. Good question.
Yeah, question two.
All right.
Yeah.
And then we'll do Kush, and then we can be done.
So I had two questions. One is, did you have AI help you make the spreadsheet?
No, the spreadsheets never has any AI involved because I'm just writing about myself. I'm pretty good. I know a lot about myself. Kush.
Right.
More serious question is,
Yeah.
do you see this research substituting for or complementing any of the interpretability research? So is it less important to understand how models work if their behavior is verifiable, controllable, cryptographically checkable, that sort of thing?
Great question. So you asked, does this supplement or replace interpretability research, e.g. mechanistic interpretability, which is the idea that we take the model weights, we build some separate system that's able to interpret why it made the decision it made. I think it complements them, because that is just another inference of a language model at some level, or maybe it's not a language model, maybe it's just linear regression on these vectors. That is a really useful thing to make auditable and verifiable, and maybe to make private. So I think they complement well. I also think auditability and and verifiability is more important than interpretability. So in a legal context, people commit crimes, and then afterwards we put them in the courtroom and they say, I did this crime because blank. And we do not take it on face value that human beings are telling the truth when they explain why they did a thing. Instead, we study the facts of the case, and that allows us to interpret what the decision should be. And it's less based on like vibes and what you thought you did, and more about what happened, mostly. I think the same is true in AI systems. It's about what did it access, what did it do, was that wrong? Not like what neural circuit did it use to come to the decision where something went wrong. That's my answer. Great question. The questions keep growing.
I'm trying to understand, great talk. I'm trying to understand your opt-in regulation that you were kind of idea that you were talking to Brad about. So is this, am I imagining, like let's say you have a bunch of AI agents and no regulation, that's like the dark web. So if I'm going there, I'm like basically saying I have access to these agents, I can do whatever I want, but I'm like losing that, like I'm losing that, like you know, I'm giving up something. Versus like when you're not on it, okay, then I'm like opting in for a certain regulation. Versus if I go to like inside MIT, I'm opting in even more. So is this kind of, you see this kind of?
So it's kind of like using HTTPS, right? Like the secure web stuff. Tons of websites you can access without HTTPS, like no security. It's fine, you can use it all the time.
No, come on. Google page rates the PS really differently. So it's money on the table.
Absolutely, which is
right?
why everyone does security. It's because web browsers will tell you this is a naughty website.
Regulation, in a sense.
I get, but instead of it being regulation, it's a financial incentive because the communities have coalesced around security, which is what I think can happen with AI. But I agree. I 100% agree with you. And I think it's a good example of, it's not government regulation. It was the team at Google responding to the fact that unsecure websites were worse.
And the reason they did that is because they knew that if they didn't do that, they would make less money.
Yes.
But let me ask you a different question.
It's also because of regulatory, right? Also because they're afraid of
Yeah,
lying.
well, that's how they're
Yeah.
going to lose more money, right? Is it,
So it's like, in the end, it's sort of, I'm making a joke, but it is kind of the fear of the EU that like drives a lot of decision making at Google to like.
So they decided it was basically free for them.
Yeah.
And it would get them out of a liability.
And so if people are afraid of things going wrong, and so they're afraid of being regulated or stepping on the wrong toes, e.g. EU AI Act, then they're incentivized to implement security. Even if it's not in the letter of the law, you must have security.
So I have a question, which is, I'm going to use his slides.
Not about regulation.
Well, no.
Go.
This is, everything you're talking about here, pictures an AI as an AI, right? But actually, there's like going to be lots of them, and they're all going to like work with each other. And we know when you get a bunch of things in a network that are all running around, that sometimes catastrophes happen. Every single AI is well-intended, well-regulated, it's doing the right thing, but the interactions cause cascades and collapses.
I feel like you're fishing for comments on papers I'm currently writing.
Well, no, I'm asking you to think, are you writing the right paper?
So I think there's two parts to this. One is there's a new protocol called the agent-to-agent protocol, A2A, which is a tool for agents to communicate. I think this is yet another good example where tech company comes out with protocol has insufficient security, community says that's insecure, and then we invent security for it. And having auditability, verifiability as part of that, authenticated delegation in this workflow is really important to monitor the complex dynamics of the system. And once you have the data on all the interactions, then there is an interesting academic modeling challenge on the system dynamics of them. And I think it's very hard to do.
I think we better do it real soon.
Yes.
The point, just for, is that financial systems, all these things are getting lots and lots of agents, and when they begin interacting, they can cause really catastrophic things, even though each individual agent is secure, happy, well-intended, just because of the dynamics of the interactions.
I mean, the next logical step of that thought pattern, Sandy, which is then someone says, well, why not just have like one agent manage it all and like coordinate everything so you don't get those things?
Because then that's autocracy.
Of course. That's what I'm saying. Like,
There's a whole
Yeah,
series
yeah.
of
Well,
conversations.
so like in
Yeah,
high
that's
frequency
good.
trading, right,
Yeah.
what they do is they monitor the frequency of things. So there's a cop, basically, that says, wait a second, this is getting crazy, let's slow down the party.
Yeah. And
Okay? So it's not actually running things, but it is sort of turning up the gas or turning down the gas.
And like to concretize this for those in the audience who have not been part of this conversation on an ongoing basis, you can imagine a context where everyone's using AI agents to code in a company, and that agent is incentivized to write code that's really good for you, to optimize for you, not the whole system. And so every time you want it to do things, it rewrites core functions to be useful for your use case. And if everyone's individual agents, which are not aligned in a multi-agent context, but only aligned to an individual, then you're going to have this degenerate code base where everyone is rewriting their own functions, there's no code reuse, security principles are different across it. And then that is kind of the code example. There are financial examples. There are lots of contexts where having multiple AIs trying to achieve a unitary objective fail at the kind of the Nash equilibria problem together.
So I think the thing that he showed is, everybody knows that on a highway, we have cars driving along. When you reach a certain density of cars, any little thing, somebody just slowing down a tiny bit, causes a traffic jam. Everybody's driving correctly, everybody's performing well, but the ensemble has crashes.
Cool. One more question. Two more questions. Both together.
Yeah, two more
Okay.
questions. And then
I was curious how these systems integrate with local AI. Also, whether you think we even need local AI for privacy if we have either verifiable or auditable AI systems.
It's a good question. So there's how, the question was how do this whole idea interact with local models or edge models or models on your phone? Essentially, all of this still matters, I think, except for that box there, the inference, right, and security of the thing. So still, even if you have a local model and you want it to tell you about the news and then plan your day accordingly, it still is interacting with an external server, the web, to do search, and it's still taking actions, which might involve interacting with other services. Even if those services are on your phone, I think security still matters in some sense. So even with edge models, I still think the rest of it is important. Also, there is a question of to what extent are edge models useful versus larger models? Maybe it's that you have a small model on your device, and then if the question is too hard, it offloads that to a large model. That's how Apple Intelligence works. And in that instance, you still need security. So I think it's a great question, and I've kind of designed this around that question such that we can plug it in as needed. It's good.
it's also worth remembering that there are bad people who are trying to break it all.
Yeah.
And you had better protect yourself.
Lots of bad people. Speaking of.
I think we have a good last one. It's very cool work. So I'm just curious, given all the stuff you did, what are like the top 3 problems you're most excited for the next 2 years?
What are the top 3 problems I'm most excited for the next 3 years?
This sounds like one of those papers, the top 10 problems.
Top 10. It's like a BuzzFeed listicle.
Yeah, but this is easier. It's only 3.
I actually think the hardest part of this question is the next 2 years. I have just no idea what 6 months looks like, let alone a year, let alone 2 years. I think in the immediate short term, the agents protocols got invented 6 weeks ago, and we had a paper out before them, then they got invented, inboxes blew up. We need to build robust security tools for them. It's kind of a big package thing. It's agent security right now. I think lots of these things, e.g. especially in the inference space and retrieval security space with trusted hardware, is good, and it needs to be refined and scaled up, and then once it's working, be used everywhere. Currently, most inference on most GPUs is not using the secure enclave. Right? When you use OpenAI, they're not doing that. And it is still, it works, it's in production, but it's not great. I think scaling that up. And then I think figuring out how questions of alignment and more kind of wishy-washy AI questions, no offense, fit into these things. How do you do evaluations on agentic behavior as opposed to just running a full loop? It's actually a bit hard technically to do that. How do you do verifiable evaluations? We can do evaluations on agents, but how do you make them more robust and mapping these to kind of new use case paradigms in this?